Hello everyone, and welcome back to All About AI Tech. Today, we're celebrating a monumental achievement in the world of artificial intelligence. Demis Hassabis, the brilliant mind behind DeepMind and the revolutionary AlphaZero program, has been awarded the Nobel Prize in Chemistry. That's right, the guy who cracked the code on superhuman chess playing is now a Nobel laureate. This isn't just a big deal for AI, it's a giant leap for humankind. Think about it. The same innovative thinking that dominated chess and Go has unlocked the secrets to accurately predicting protein structures. We're not just talking about a clever game. We're talking about potentially curing diseases, revolutionizing medicine, building a sustainable future. The images flashing before you show just how far AI has come and the incredible potential remaining. We'll be looking at some of those images later, so stay tuned. Isn't this genuinely inspiring? Let me know in the comments what you think about it all. So, let's rewind a bit and talk about AlphaZero. Remember, before AlphaZero, chess engines were built using a combination of human expertise and brute force calculation. Chess grandmasters, experts in the game, would hand-code crucial elements into the algorithms, effectively teaching the engine about strategic principles and positional understanding. These algorithms would then be combined with alpha-beta pruning, a clever way to search through possible moves, trying to find the absolute best one within a human-defined amount of time. But AlphaZero completely changed the game. It was trained using only the rules of chess. No opening books, no grandmaster insights, nothing but the basic rules of the game and a deep learning algorithm. It learned by playing itself, millions upon millions of games. The images I'm displaying show AlphaZero's unconventional and dynamic playing style. It showed something very different from how previous engines had played the game. Imagine the sophistication needed to create something that could learn and adapt at this level, without any explicit human guidance. Just pure, relentless self-improvement. Through reinforcement learning, it identified optimal move selections, boosting its win probability. It mastered chess in a mere 9 hours, Shogi in 12, and Go in 13 days. AlphaZero demonstrated an approach so innovative that top-level competitors are still working to understand it. One of the key innovations behind AlphaZero was the use of Monte Carlo tree search, or MCTS, combined with reinforcement learning. MCTS is a search algorithm that doesn't simply explore every branch of the game tree, all the possibilities within a game, but rather uses a statistical approach to evaluate the most promising paths using random sampling. It essentially guesses and learns from experience. This made it incredibly efficient, allowing AlphaZero to achieve superhuman results even with limited computing power, even more so than previous engines. Reinforcement learning is where the real magic happened. Unlike other AI training, reinforcement learning isn't about telling the AI what to do. It rewards it for success and penalizes it for failure. With this system, AlphaZero learned on its own the best way to play these games to win. The images you're seeing here show how the MCTS algorithm works. You might be surprised to see how simple some of the AI mechanisms behind AlphaZero actually are. In this video, I'll present exactly why the algorithms are effective through the examples of various game situations, from the very early games to some of its best wins. Now, the impact of AlphaZero wasn't limited to DeepMind. Its success inspired the open-source project, AlphaZero. Imagine a team of dedicated programmers taking inspiration from a published paper on AlphaZero, completely replicating its methodology without the same immense computational resources. That's what happened when AlphaZero was created. It's a testament to the power of open collaboration and driving innovation. This is fantastic, showing that it's community efforts, as well as corporate ones, that help move AI forward. AlphaZero, using a similar approach to self-play and MCTS, quickly achieved grandmaster levels of strength. And guess what? This open code allowed the wider chess community to participate in improving the game, adding value and contributing to its overall development. The images I'm showing here compare some of Leela's earlier games to later ones, highlighting its progress and development. Pretty incredible, wouldn't you say? But Demis Hassabis didn't stop at chess. With AlphaZero's success under its belt, DeepMind had a much bigger goal. They tackled a problem that had stumped scientists for decades: protein folding. Proteins are the building blocks of life in every living thing, and understanding how they fold into their 3D structures is critical for developing new medicines and therapies. So, that's next. AlphaFold was created. This is where Hassabis' genius truly shines. Instead of using traditional methods to analyze protein structures, which were incredibly time and resource-intensive, they applied the principles behind AlphaZero's self-learning abilities. AlphaFold used deep reinforcement learning to predict the complex 3D structure of proteins. The accuracy and speed have been incredible. The images here showcase the incredibly intricate nature of protein structures and how AlphaFold can predict them in minutes. The speed and accuracy demonstrated are breathtaking. Think about the potential for breakthroughs in medicine, the development of new drugs, and the speed with which it operates. All of this work would not have been possible, let alone as effective, without AlphaZero. The impact of AlphaFold has been nothing short of revolutionary. It's already being used by researchers worldwide to make significant advances in various fields from enzyme design to drug discovery. Now, AlphaFold 2 is pushing the envelope further. We're talking a free, open-access database that contains over 200 million 3D protein structures. 2 million researchers from 190 countries use these predictions, all for free. Think about the global collaboration fostered by this incredible resource. It's democratizing scientific discovery, empowering researchers across the globe, irrespective of their resources, to push the boundaries of scientific knowledge. The images you see here represent just how impactful the work on AlphaFold is. We could solve countless of the world's deepest problems with little cost. Is this not an incredible accomplishment? And now, the culmination of all this incredible work, the Nobel Prize in Chemistry. Demis Hassabis and John Jumper, a lead researcher on AlphaFold, have shared the prestigious award for their monumental achievements in protein structure prediction. It's a truly well-deserved recognition, a validation of his visionary approach and the immense impact of his work. The images here show the official announcement of the prize and some of the celebrations surrounding the honor. It emphasizes how important this specific work is. This isn't just about recognition of a singular accomplishment, but a testament to the power of dedication to scientific research and innovation using AI. To be able to impact the lives of billions of people through this type of research, surely that's the ultimate reward, isn't it? This is an exciting time to be alive. The advancements of AI are rapid, and the potential is limitless. Demis Hassabis' Nobel Prize serves as a potent reminder of the potential of artificial intelligence to impact the world positively. This breakthrough opens doors to countless possibilities. It's a testament to the transformative power of AI in accelerating scientific endeavors, and this is only the start. The implications of AlphaFold are already impacting various scientific fields and are poised to make profound contributions to human health, environmental sustainability, and countless other areas. From solving the puzzle of protein folding to applying that same logic to other scientific challenges, the possibilities are endless. The images shown now illustrate various ways that AI can help us move our scientific understanding forward. Don't forget to subscribe, and I hope to see you all next time.